Hello Year 12, welcome to this week's weekly review where we're going to be looking at computer protocols including TCP/IP, and we'll look at the homework and some model answers. So to begin with, let's look at an overview of the TCP/IP protocol.
TCP/IP model and how it relates to the internet and similar computing networks. The TCP/IP model is a set of communications protocols that were developed by the Department of Defense and released in 1974. As you may know, a network protocol is a set of rules governing how data is exchanged in a network. When it comes to network protocol, the TCP/IP model is like the official rulebook. It has end-to-end knowledge on how data should be packetized, addressed, transmitted, routed, and received. Without the TCP/IP protocol, most computers wouldn't even know where to begin when it comes to sending your best friend a picture of your cat. But how can we hope to understand the TCP/IP rulebook? Well, smart people from around the world have separated the protocol into 4 distinct layers and creatively called it the 4-layer model. The layers are the application layer, the transport or TCP layer, the internet or IP layer, and finally the network interface. Let's go a little more in detail about these layers now. First is the application layer. This one is the easiest to understand because if you're watching this video on YouTube, you're on the application layer right now. Simply put, the application layer contains all programs such as web browsers and web servers that exchange information. Its job is simply to send files and information to the transport or TCP layer to be, well, transported. Now, the transport or TCP layer of the 4-layer model really doesn't care what the application layer has just sent it. It's only interested in how the information sent is going to get to its desired location. It's at this time that information is packetized. The transport layer of the TCP/IP protocol cannot send the information in its fully assembled form because it's just too big and too complex. So, the transport layer's job is to break down the information into smaller parts, called packets, and they're only really 1 kilobyte in size. Then, these tiny packets of information are sent to the internet, or IP layer. The internet, or IP layer, only deals with these things called IP addresses. An IP address is similar to the address for your house. It is the exact location where a specific network can be found. The internet or IP layer is interested in addressing each tiny packet with the proper destination and then sending it on its way using the proper network interface. The network interface is the central hub where all information in the immediate area passes through. This is what Wi-Fi, Ethernet, and DSL are. Without a way for the packetized information to travel, no information would ever be shared. Now, this may all sound a little confusing still, so let's apply this to a scenario. Imagine, for instance, that you're trying to send a puzzle you've already completed to your friend through the mail. When you take the finished puzzle to your local post office, this is the application layer. When you're at the post office, the postal worker decides it's easier to send each puzzle piece individually than it would be to try to send the puzzle completely intact. And so they disassemble the puzzle and package those small pieces. This is the transport or TCP layer. Now that each individual puzzle piece is smaller, it's sent to the back room of the post office, and stamped on each box is your friend's specific address. This is the internet or IP layer. Next, another worker looks at each address that's being stamped and puts it into a specific truck in order to be delivered. This truck is the network interface. It is how information is moved between different IP addresses. Once the truck delivers the packets, your friend receives each puzzle piece and reassembles it in order to see the final picture. The 4-layer model is being used constantly whenever you're on the internet. It allows you to print remotely, share images with friends, and so much more. While you may not be sending any completed puzzles to friends in the future, hopefully this video helped you to gain a clearer image of what is happening.
So you've seen an overview of the TCP/IP. We want to look at the questions and in particular some homework answers. So what is this idea? You've got to explain what the IP address is, and if we look at some model answers provided by Tom, we can go through it with regards IP. So you've seen in the video that it's an addressing system. So there's 3 mark points here. I'm looking for 3 pieces of information from Tom. So it's an addressing system. Tom mentions that each computer has its own address, and just as you've seen here, it allows in the video, it allows information to be sent from from a sender to a recipient. So information to be sent. Then another fact is it's 32 bits long. We've got, it says, 4 groups of 8-bit numbers. And again, it would help to aid with an example. So for example, you might have an IP address 192.6.0.1. Give an example of an IP address. Next, the difference between this is, Tom also mentions the idea that we've got static. Some IP addresses are assigned to a device or a segment of a network and don't change. Others are dynamic and they're allocated through a protocol DHCP. So when you connect to a router or device, you're allocated a temporary IP address. And again, it will identify you in that network. Next question when we were looking at protocols was the media access control address, a unique identifier used at the network layer in the model that we've just talked about. We need to be able to send data out onto a network and be able to identify. So I'm looking for 3 marking points for the MAC address. Well, you'd probably get 1 for the explaining what it is, but more importantly, it's assigned or it's hard coded onto the network interface cards. They are unique, or you should say they're used to uniquely identify the devices on the network, and they're provided by the manufacturer. And you could explain that the first 3 octets are assigned to the manufacturer, the other 3 identify the device. Generally, what is a protocol? You should be giving 2 mark points for this. It's a set of rules, but remember, it's a set of rules governing how information is sent on a computer network. So again, I'm looking for network. And then the final question you've just seen in the video, really this concept of what is TCP/IP. We've seen that it's a stack, that there was 4 layers in this stack of rules. So we're looking for 4 mark points. You didn't necessarily have to go into explain every element of the rules. But you've seen at the start of the video, it's to do with the packetization, how data are broken into small packets, how data is sent out over a network, how data is addressed on the network, and how data is reassembled. So really looking for that, breaking down into packets, sending it out and addressing on a network, receiving it and reassembling it. Each data takes its route and it goes to the expected destination. When it's received, the packets are reassembled. This idea that it's responsible for reassembling to form the file. Tom does mention the idea that we've got layers here. It's divided into multiple layers and each layer has its own job, as you've seen in the video. After the file is downloaded, it'll pass through the set of layers of the destination file and it's reverse order. So this idea that data is converted into a packet, it's transmitted and addressed, and the layers, let's say 4 layers, and they look after sending and reassembling the data. So you have a model answer there, folks. You've seen the video, and make sure you read through the model answers and have a sound understanding in particular of what a protocol is and TCP/IP. Chat next week.